Let's take a look at the answers to the Chapter 3-4 quiz. True or false? Remember, if you can come up with a counterexample, a statement is false. So let's see what we've got here. If a triangle is equiangular, it is also equilateral. Remember, we've got a theorem that says in a triangle, if angles are congruent, the opposite sides are congruent. Okay, but if I apply this to another angle, then the two sides opposite, any of the two angles would be congruent. That is a true statement, okay? An equilateral triangle is also equiangular, and equiangular triangle is also equilateral. Number 2, an obtuse triangle can have a right angle. Well, an obtuse angle would be greater than 90 degrees, so, maybe like 120 or something like that. Right angle would have to be 90. You can't add a 90-degree angle and an angle that's bigger than 90. You'll get something that's greater than 180 degrees, which is the sum of the angles for a triangle. So that's got to be a false statement. An obtuse triangle has one obtuse angle, and the other two have to be acute. Number 3, the median from the vertex to the base of an isosceles triangle is also an altitude. Well, let's check. So I've got an isosceles triangle. Here's the median from the vertex. Okay, you can usually think about these in terms of triangle congruence. So it's a median. These are going to be congruent. Okay, and that's going to force the two triangles to be congruent by side, side, side. Okay, if that's the case, these two angles are congruent and they're supplementary, which means they're right angles, and that's going to be an altitude. Or you could use the equidistance theorem. This point is equidistant from the endpoints of the base segment. This point right here is equidistant from the endpoints of the base segment. That means that this line right here is going to be a perpendicular bisector. So a couple ways to think about it, but yes, that is a true statement. For an isosceles triangle, the median is also an altitude if it's going from the vertex angle. Okay. Number 4, a triangle with exactly two congruent angles is isosceles. That is correct. If you've got two congruent angles, the opposite sides are congruent, and it'll be isosceles. True statement. Number 5, the median of a triangle is also an angle bisector. Now, this one, in a way you think, oh, yeah, sure, I can draw an isosceles triangle, and I can draw a median, and yeah, it's going to bisect the angle because, we showed up here that we get two congruent triangles. But be careful. Not all triangles are isosceles, okay? If you pick a scalene triangle, for example, the more exaggerated you make it, the more obvious this is going to be. The median is the midpoint of the side, okay? Normally we prove congruent angles by proving congruent triangles. We have no reason to think that these two triangles are congruent. This appears to be obtuse. This triangle is not obtuse, okay? As a result, these two angles would correspond. There's no reason to think that that angle is equal to that angle. And so, no, that is a false statement, okay? The median does not always bisect an angle. Okay, draw a sketch in number 6. So DEF, and by the way, you could try to draw it to scale. DE is 7, DF is 8, EF is 9. I did not draw it to scale. But remember, we know the largest angle is opposite the largest side, the smallest angle is opposite the smallest side, and so on. So the smallest angle would be opposite the smallest side, and that would be angle F, or you could call that angle, EFD, DFE, that sort of thing. Or you could try drawing it to scale. Clearly 3 different side lengths. You could say, well, the small side here has got to be DE, and that's my 7. And my middle side has to be DF, which is my 8. No, my picture's not going to work very well for that, is it? EF is my long side. So actually, I'd want to do ED like this. And then DF is 8, and then EF is 9. And you could actually see here your largest angle is opposite your largest side. So pictures sometimes can give you a pretty good guess, but again, we really have that theorem that makes it easy for us. All right, we have an isosceles triangle. Remember, the legs are the congruent sides, so if one is 8, the other one's going to be 8. We want to find the missing side. We can take those two 8s away from 21, and 21 minus 16 is going to be 5 is our missing side. All right, find the value of x in the diagram. This is a 130. I see a straight angle here. Subtract from 180. That's going to be a 50. It's an isosceles triangle. Two congruent sides. Immediately mark your two congruent angles. Okay, and what that means is 180 minus 50 is 130. That 130 is going to be evenly broken up. So half of 130 is 65. We have 65 in both of those positions. And then we have a straight angle. 180 minus 65. It's going to be 115 degrees for x. 4 rules to prove triangles congruent. We still have one to learn, but we first learned side, 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 and then we learned the side angle side rule, and then we learned the angle side angle rule, which is not what I just wrote there. And now we have the new rule. Your book calls it hypotenuse leg. I prefer to call it hypotenuse leg right angle. I will take either one. And there is one more, but we haven't gotten there yet. All right, moving on to page 2 of the quiz. Right angle theorem, section 4.3. Two angles are right angles if they are both congruent and supplementary, or I guess actually our book says supplementary and congruent. Okay, we've got a circle, diameter endpoints at -1, 2, and 3, 9, and you make a sketch and you realize, oh, I need the midpoint. Midpoint's the average of the x's. Add your two x's together, divide by 2. The average of the y's. Add the two units together, divide by 2. Okay? I like to line mine up, by the way, -1, 2, and 3, 9. And anyway, 2 plus 9 is 11, divided by 2 is 5.5. It's going to be halfway between those two. And -1 plus 3 is 2, divided by 2 is 1. 1 will be halfway between -1 and 3. So my midpoint will be 1, 5.5. Okay? I'm not sure if we had one of these come up in class. We have a segment with an endpoint at -2, 5. The midpoint is 4, 1. I line these up. In other words, you're going to move the same way from, so if this is one of your endpoints and this is your midpoint, look at what you're doing. If it's going to be a straight line, you're going to do the same thing to get from your endpoint to your midpoint as to get to the next point. So if you notice here, from -2 to 4, we increase by 6. So if we increase by another 6, that'll take us to 10. Meanwhile, from 5 to 1, we subtracted 4. And if you subtract another 4, that'll take you to -3. Okay, so that's how I would do it. The other way to do this is to do the formula. Remember, we're averaging the x's. So x1 plus x2 divided by 2. That's our x-coordinate. That x-coordinate of the midpoint is supposed to be 4, right? And we know x1 is -2. So we have -2 plus something divided by 2 is supposed to be 4. So -2 plus x2 all divided by 2 gives us an x-coordinate of 4. We can double both sides. That's -2 plus x2 is equal to 8. And so x2 is going to be 10, right? And that's what I had up here in my previous version of the answer. Same thing with the y's, right? You're going to average the y's. y1 plus y2 divided by 2 needs to give us the y-coordinate of the midpoint, which is 1. So set that equal to 1. They gave us y1 to be 5. So I have 5 plus y1, all divided by 2 is equal to 1. We can double both sides. That's going to give us 5 plus y2 equals 2. And that makes y2 -3, right? You can see that answer there. So you can kind of think backwards through the process. A couple different ways you can do it. All right, angle relationships. Corresponding angles are in the same position. So that could be like angle 1 and angle 5. That could be like angle 2 and angle 6. Top right, top right. That could be like angle 4 and 8. Bottom right, bottom right. Angle 3 and 7. Bottom left, bottom left. Alternate interior angles. Alternating sides of the transversal on the interior. That could be angle 3 and angle 6. That could be angle 4 and 5 are also on alternating sides of the transversal. Remember, a Z shape will kind of zigzag around your alternate interior angles. Same side interior angles. 4 and 6 are on the same side of the transversal on the interior. 3 and 5 are on the same side of the transversal on the interior. And finally, alternate exterior angles. Alternating sides of the transversal exterior angles. That would be either 1 and 8 or 2 and 7 in my particular example. All right. Remember that lines that are perpendicular have opposite reciprocal slopes, so -5/1. If you flip it and flip the sign, you're going to get +1/5. Okay, AB is congruent to BC. AD is congruent to DC. By the way, I notice here, notice that point B is equidistant from the endpoints of AC, and that point D is equidistant from the endpoints of AC. So that means that this is the perpendicular bisector of AC. It's going to be perpendicular to it, and it's going to bisect it. You could probably prove a bunch of congruent triangles there too, but I think that's going to be helpful. So anyway, what do we got here? AE is 4x minus 1. EC is 2x plus 7. Okay, they give us other stuff, but right there, this is bisected, right? So I know that 4x minus 1 has to be equal to 2x plus 7. Subtract 2x from both sides, we get 2x minus 1 is equal to 7. Add 1 to both sides, we get 2x is equal to 8. X is 4, right? And they want the length of BD. Let's see, BE is 8. And they said ED is 3x minus 1. So now I know what x is. X is 4. 3 times 4 is 12, minus 1 is 11. So 8 here, 11 here. 8 plus 11 is equal to 19. And I'll do the proofs on a separate video.